Hello, everybody, and welcome to the first ever episode of the GCP.LIVE Podcast. We are live today on episode 01, and I have with me Aniket Goel. Aniket is a dear friend of mine. We work closely with each other at Media Agility, and Aniket does some exciting work. Aniket, welcome to the show. Can you tell us a little bit about yourself? What is it that you do?
Thank you, Arpit. Yeah, sure. So I'm Aniket Goel, working with Media Agility as a delivery partner in AIML deliveries. I've got 15 years of experience working in IT industry and have a profound love for data since the beginning of my work. I've worked on complex data architectures in past and how these data architectures are reshaping for new world of big data and application modernizations. I'm here in Media
Awesome.
Agility to ensure that the clients can leverage their data by translating the data into data driven actionable insights.
Very interesting. Data driven actionable insights. That's very interesting. Can you maybe go a little deeper into what do you mean by data driven actionable insights, and what does it take to generate insights from data?
Absolutely, Arpit. So, Arpit, like I would like to emphasize on data-driven actionable insights by taking you to the journey of analytics itself, how the analytics in the IT industry have evolved over the years. Over the years, horizon of data have changed, and so the business expectations from the data. The business
Hmm.
today wants real-time insights from their big data, like not a small
Hmm.
size data or something data which is at rest, but also on the live data itself. So through ages, most of the industries were already data rich and were doing descriptive analytics. So that's the first pillar of the analytics, a descriptive analytics. These were the basically what we say as reports or the dashboards which are created by the machines for the humans. Now over there the human intervention came in and humans understands what the business is doing. So basically these reports or the descriptive analytics is to give you an answer to a simple question: what happened? So what happened to my business?
Yeah. So financial reports, operational reports, IT reports. What is happening in my business right now? Got it.
Correct, correct. So, for example, let's say sales, my sales were X in the last quarter, or my financial earnings for the last financial year was Y. So, the answer of this X, Y, how many customers I have got, what is the running rate of the customer, those were the questions being answered by the descriptive analytics. But the
Hmm.
business became really curious. Okay, and then if business knows what has happened, the obvious question of the business would come: why did it happen? So
Hmm.
then, instead of humans to analyze manually this data, the answer, in order to give the answer, the data tools were built to reduce the human intervention. Now, which led to diagnostic analytics, which is to answer if the sales were X in the last quarter, why so? So, what made
Okay.
the sales to reach to the figure of X?
Hmm.
That is where the diagnostic analysis started answering more insightful questions like something happened, why does it happen? Now, one thing is leading to the other. If machines can understand why something has happened, why not turn that question and ask the machine what will happen? Now, this
Hmm.
is where the predictive analytics came into existence. When diagnostic analytics found the relationship of business outcome with known inputs, the same is utilized to predict what could be the future outcome.
Hmm.
Here, basically, machine will answer the question based on what business knows as the input for future, what will happen. So let's say I understand that the sales for my business is a 10 million sales because I have got 50 employees working in this field. I have got this much of advertisement going out, this much of marketing spend, this much of financial spends, and the other factors. So these factors are related to the output. And I know that in next quarter, if I put up this much of money for marketing, this much of money for my financial services, this much need this many employees, how much sales can I make? So
Yeah.
that is what
So we
future is
started with
trying to
what was my sale
yeah,
last quarter, and then we said, okay, why was my sales X, or why did I grow my sales, and or why did the sales decline? And now we are saying, based on what we know, what would be my sales next quarter. So that's predictive
perfect,
analytics. Okay.
perfect. But till now, we were seeing that the human inputs for this analysis is reducing, and the machine are automating the things. So instead of humans working and crunching the data a lot, machines started doing it. But if we look deeper, okay, does this is changing anything for the, like, changing anything real for the business, other than just giving you simple answers to the questions like what happened, why did it happen, what will happen? But it is not really changing anything for the business. So the real
Hmm.
power is not just to predict or know the future. The real power is by making the future the way that we want it to be. So basically, winning the bet by good odds. This led to the fourth and the final pillar of the analytics, called as prescriptive analytics, which answers the question, now that I know, what do I do with it? So, this
Yeah.
fourth pillar is the basic principle of your artificial intelligence, in
Hmm.
which, with minimal to no intervention of human, machines are asked to make decisions. And I call this as data driven actionable insights.
Yeah. So we went from descriptive analytics to diagnostic analytics to predictive analytics and now prescriptive analytics. And obviously, all companies need all of them. It's not that you only need one or the other. The If you don't have, as a company, if you don't have any analytics, it's a good idea to start with basic descriptive analytics to understand what data exists in your organization. How's my sales doing, how's my IT doing, how's my HR doing. Every department needs to have some sort of a reporting so that you know what's going on in your company. But then once you have that matured, obviously you can go to higher levels of analytics and talk about diagnostics and prescriptive and so on and so forth. So and one thing is clear, the skill set required to produce these analytics is very very different. All right, so the different set of skills required to produce descriptive analytics, and then a different set of skills required to produce diagnostic and predictive and prescriptive analytics. So let's talk about some of these skill set. Aniket, I know you have a big team. What does that team look like if you have to do the end to end spectrum, and we work with a lot of clients to do this? What does your team look like? What are the different roles, and how do you determine what work need to be done to produce all of these different insights?
Yes, surely, Arpit. So basically, over here we're talking about the spectrum of the data work and how and which roles try to fit in where. So let me start from the base of the first pillar, which is descriptive statistics. And if I say what is being covered over there is basically standard reporting or the descriptive statistics. Now, this is a kind of a role which a data analyst usually do it. So data analysts are one which can run queries, optimize the queries. Basically, they can do lot of mangling of data, data visualization, right? So those are the basically the roles and responsibilities I would highlight in terms of being a data analyst, which are doing your descriptive statistics. Then
Okay,
over,
so data analysts, so they have the data and they analyze it and
right.
they tell you what happened. So they're doing descriptive analytics. Got it.
Right. Now, diagnostic analytics is where you basically do more deeper understanding of what has happened and like why did it happen. So diagnostic is coming in why something has happened. So you need to crunch the data into more actionable items, or basically understanding the data into a deeper end sense, when I will bring in data engineers to play. Now, data engineers, why so? Because they can design and maintain data management systems. They can collect or put the data into a data pipeline which can be used to analyze your data and understand what is happening with your data on a real time,
Yeah.
finding hidden patterns from the data. So data engineer, I would like to put into perspective wherein they can automate the reports, they can produce the things for you as in like from the starting of the source of the data to the end where you wanted to keep the data for.
Yeah. So basically, we need to understand what data exists. So if you have the data and you are able to analyze them, that's the job of a data analyst. And we're going to talk a little bit about the tools that are required as well. But let's talk about the roles first. So once you analyze the data, you know what's going on in your organization. But sometimes your data may not exist in one place. So you need to get data from different places, different systems. Your sales system might be totally disconnected from your other client management system or operation system and things like that. So how do you connect all that data so that you know why your data is giving you a number, right? So when a data analyst gives you a number or gives you an insight, why is that insight so if you're trying to diagnose it, you need to connect that data with connect the dots and look at all the data together, and that is where a data engineer can help in really connecting your data and bringing all the data together, and also try to explain what is happening with it over time, and that's where the data pipeline concept comes into play. Got it. So we talked about the data analysts and data engineers. What other roles exist in this realm?
Yeah, so the next one is to, when you are moving towards a prediction or understanding what could happen in the future, but you're looking at the past of it. Now the humans are not looking at, we need to make the machines learn what the business is doing by looking at the historical data. So that is where the machine learning engineers comes and fills that role. So learning engineers are the one I'll describe, who design and develop machine learning systems, learning the historical data of the business. Researching on machine learning algorithms is one of the role of the machine learning engineer. Then you need to test what you have produced, developing apps, products basis of the requirements, and extending machine learning frameworks and libraries for multiple supports. Training and retraining of the systems, so you need to continuously keep on learning from your historical data and the data as it grows in the life, and make sure that the models are up to date. So all these tasks I would fit into the machine learning engineer perspective, when they try to learn the historical data and then predict it for the future.
Yeah, so I think let's quickly explain what is machine learning. I don't know if we talked about that, and we're not going to spend too much time on it because we talked about predictive analytics. And but what is machine learning for those who are listening?
Yeah, so for a novice I would explain machine learning something like how your traditional IT industry was working. So for me, when I joined the IT industry 15 years back, what I saw is there was a business analyst or um, business guy who brings the the rules for the business to me. So he tells me, like, let's say tomorrow a customer comes to you, you ask these five questions to them. If the answer for the first question is between these values, the second question answer is between these values, you do something. So basically we were defining the rules manually. Somebody from the business will come to me and tell me, this is my how my business works, these are the rules you need to code. So the IT industry was coding the business rules manually. Now over the time we saw, with the increase in data and the increase of processing power, why to write the rules for especially complex scenarios where you cannot answer the question very easily in terms of rules. For example, you need to distinguish between an apple and an orange. So there are two images in front of you. As a human, if I look at the apple, I identifies it, I recognize it very quickly. Okay, it's an apple and it's an orange. But how will a machine understand it? If I have to write a rule for it, I might start with what is the color of that object is, what is the texture of that object is, and so on. Maybe I'll try to drill it down to, let's say, 50, 100, or 1,000 lines of rules to differentiate between them. But as soon as a new object comes or a little deformation is there in that object shape, the machine might start falling.
Yeah, what
So
if it's a green apple or a golden apple or a
perfect.
green orange or a cut apple or a half eaten apple? So there are so many rules.
So
So
many, yeah. So there can be so many variations, so many rules. Now it becomes almost impossible for a human to write those rules. That is where this machine learning concept started. So instead of telling that you do this based on this inputs, let's machine understand itself. Basis of mathematical algorithms, let's machine understand what is the difference between the two. So I'll give lot of historical examples of different types of apples, different types of apples images and oranges images. I'll say, okay, these are the 1,000 apple images, these are 1,000 orange images. Let's bifurcate that. So machine will start writing the rules. Instead of you giving them the rules, the machine will write the rules looking at the historical data. And that's what the machine learning is changing. So code was first. So basically there is code and rules. Traditionally the rules were provided by the business, the IT engineer used to write the code. In the machine learning, the data is provided by the business, the rules are generated by the machine learning.
Yeah,
And
so it's
that's
very similar to how humans learn, right? So we nobody tells us how to identify an apple or how to identify an orange. Our parents must have shown us what an apple looks like many years ago when we were kids, and then we built an image of what an apple might look like in our heads, and now we know. So we didn't learn from rules; we learned from examples, and that is exactly what machine learning does as well.
yes, perfectly. So I've got two kids, Arpit, and basically when I teach them, I try to relate it. So when I show them, okay, this is a cat, this is a dog, maybe next time they will see a dog with a little look like as a cat, and they start speaking cat, cat. So I will
Yeah.
correct them. So basically at that
So
time,
we'll
I
need
correct
more
them,
training examples.
more
Essentially, we
training.
want to make sure there is enough training data for kids as well as for machine learning. So that is true. So coming back to our roles, we talked about data analysts who would analyze the data. We talked about data engineers who would bring data together and help you automate a lot of that by building pipelines. And then you started talking about an ML engineer. So is an ML engineer, for clarity, the one who would build models and as well as build systems to use those models, or are those in fact different roles in themselves?
Yeah, so machine learning engineers, I would divide into two roles. I would say the first role is more focused upon building something, building, making sure that the input, which is the historical data, and the expected output are matched more as much as they can. And then there is something which is about the continuous learning and the continuous deployment, which we will talk about in a minute. But I label them as more of a machine learning ML ops engineers, so machine learning operationals engineers who can put this ML code, which is an algorithm, into production and
Yeah.
ensure that it meets the requirements of the production.
Yeah, operationalizing machine learning.
Yes.
So that is primarily an ML ops engineer, or some people loosely call them ML engineers, which is also correct. So you're using ML and you're using engineering to do that. And let's talk about the person who's building these models. Is
Yeah.
that a data scientist?
So a person who is building a model, let's say, who is training these models, I'll still label them as machine learning engineers. But there are thousands, or maybe thousand is exaggerated. Maybe there are tens or twenties of different types of algorithms which you can fit on the same algorithm, like same input and output. You can apply 20 algorithms. Now, out of those 20, which one suits the better to the business? Which one should be chosen? So that choice is where the data scientists come into the play. The data scientist is more of a leg up when they can define what business actually need and how a machine learning can solve that business problem. So data scientist understands the business requirement. They try to translate that business KPIs to a model output, because business will have some KPIs. Like if they ask for something, they will be having an objective into their head. So understanding their objective, mapping it to the output is what a data scientist will fill that gap, and supports machine learning engineer to write that out.
So if I understand this correctly, what you're saying is a data scientist would look at your data, understand the business requirements, build the hypothesis, build your model. So develop the model, develop the training model that would build that would provide predictions, and then from that point on, an ML engineer might take on that model and train that model at scale with all the training data that you have available. So you need a data scientist to actually come up with that model architecture, either select one of the existing architecture or modify and build new architecture and so on. And then he or she might work with an ML engineer to then do the training at scale, right? And for all those who are listening, I want to clarify one thing, right? So these are all different roles. We talked about a data analyst, data engineer, data scientist, and machine learning engineer, and machine learning ops, ML ops engineer. These are all different roles. They don't have to be different people. In many companies, different people might be playing the same role and the same person might be playing different roles. So but these are all different roles that one needs to be aware of, that because the skill set required, like Aniket said, the skill set required to come up with a model, come up with a solution, come up with a machine learning algorithm that works for a particular situation, define the hypothesis, build that relationship, is very different than the skill set required to now take that algorithm and train it at scale on millions of data points and make sure that the model would scale, put it into production and make sure that the prediction would scale. So there are different skill sets required, and hence these different roles.
Yes.
So apart from these five roles that we talked about, analyst, engineer, ML engineer, data scientist, and ML ops engineer, which is kind of an overlap between an ML engineer. What other roles do you have in your team, Aniket, that helps you with building actionable insights for our clients?
Yeah. So one more last role I would like to define is will be a data architect role, who is responsible for developing and implementing overall data strategy for the business and organizations. So when I talk about the other roles, the first five roles we defined is more of understanding a business problem and solving that. Now, as a whole of the organization, who need to understand the data strategy of the overall organization. Is my data which is being collected, is it solving that strategy at a scale? Understanding what my goals are as a business, are they being fulfilled by the data or not? So that is where the data architects comes in. So who understands or identify data collection sources and make sure that they are in line with the data strategies. For example, let's say you wanted to have a data on a cloud or a data at house. If what are the security measures to implement? What is the efficiency at which the data should be resting? So all those questions to be at a high level to be answered by the data architect.
Okay, very interesting. So, data architect. So, all the organizations that want to collaborate with an architect to define your data strategy, what should be the security outline for your data, how should data governance be implemented, or how any of these systems might actually be set up. That's the role of a data architect. And for clarity, for those who are listening, how would you differentiate the role of a data architect than, let's say, from a data engineer?
Yeah. So data architect over here is basically ensuring the governance, security at high level, how the data is linked to your overall business strategy. The data
System
engineer,
design.
yeah, system
Yeah.
designing. So making sure that the system, the architecture is considered efficiency and the security at scale. The end-to-end architecture of the data is being put up as per the strategy. The data
Mhm.
engineer, on the other hand, is to complement what a data scientist is trying to solve for a problem statement. So data
Mhm.
engineers are bringing that data, making sure that the data is flowing through the body of the organization in a right channel. But what
Mhm.
is this body? How is this body architected? That's what the data architecture will govern.
Yeah, and a like I said above, like I said before, right? A data engineer and a data architect are two different roles, but they might be played by the same person. So it depends on the organization, the size of your team, and the amount of work that you're doing with your data.
Yes.
All right. So we talked about five or six different roles here. I hope this brought some clarity. So what's the difference between a data analyst, data engineers, data scientists, ML engineers, ML ops, and data architect? And then now let's talk about tools on Google Cloud that can help you do the same, and the tools that these people, these roles would be using. So, a data analyst, I will start with the data analyst and then we'll go one by one. So, data analyst, for example, I know would analyze a certain data that is already available. And one of the most popular tools to use that is use for that is Looker. So, a data analyst would look at the data in Looker, build different dashboards and different reports to produce insights that can be then analyzed and used by the business to make business decisions. So, Looker is a data delivery platform, data visualization tool that helps you analyze the data and make business decisions. So, that is something that a data analyst would use on Google Cloud. Let's talk about data engineer. Aniket, do you want to give us some of the tools that a data engineer would use?
Sure, Arpit. So a data engineer would use for storing the data tools like cloud storage or the BigQuery. For your ETL purposes, a data fusion or a data flow, cloud composure for orchestration.
Yeah, and one thing to note for everybody is all of the tools that Aniket is mentioning or I mentioned uh, are all cloud native managed services on Google Cloud. So you don't really have to think about spinning up infrastructure. All you have to worry about is your data and your business logic. So, for example, I mentioned Looker, which is a managed service. It's a cloud native tool. And then Aniket mentioned cloud storage, which is cloud native storage solution for blob storage. Then BigQuery is a managed global cloud-based cloud native data warehouse on Google Cloud. Dataflow is an Apache Beam runner, which is again a cloud native service, auto scales and is run in a fully managed fashion. Then Cloud Fusion is another cloud native service that allows you to do ETL by visually designing data pipelines. And then Cloud Composer is another cloud native service which helps you in orchestration. It is basically a runner for Airflow. So these are all the tools that a data engineer would use. The next, we talked about a data scientist, and a data scientist has a variety of tools that one can use from the Google Cloud portfolio. There is the whole pre-trained models on Google Cloud, whether it be Vision API, NLP API, and so on. There are AutoML suite of products which allow you to take Google's pre-trained models like the Vision API, NLP API, Speech API, and so on, and then train them using transfer learning on your own custom data, but without having to write any code. So it's a no code environment for you to build models. And then there is the whole Vertex AI platform. All of the above tools that I mentioned, whether it be pre-trained models or AutoML, are also part of Vertex AI. But then Vertex AI also gives you experimentation workbench, which is basically notebooks and experiments, and then pipelines and training routines and prediction routines. So essentially, Vertex AI gives you a full platform for you to build any kind of data science machine learning model. So that those are some of the things that a data scientist would use. And an ML engineer and an ML ops might use Vertex AI extensively as well, because Vertex AI has ML pipelines as an integrated component as well, that allows you to write modular pipeline for your machine learning code that allow you to train, experiment, and scale and predict at scale. So Vertex AI is where the data science machine learning space will happen. Let's talk about a data architect. I know there are a bunch of things that a data architect does. So let's talk about data governance, data security, everything that a data architect does. What are the tools that a data architect would use, Aniket?
So a data architect has to look for governance, security. So there are a bunch of tools like IAM on GCP for your access management, access control, understanding who can access the data. They can. Uh, there are a lot of uh, managed databases to the private databases as well on the GCP, which can be chosen by the data architect. So yeah, those are the things which a data architect is using.
Yeah, so a data architect would select different services and define what services can be used, would work with IAM to define what roles exist and who would be mapped to those roles and how, would use something like a data catalog to perform data governance, and different tools to generate lineage and define how your system design should be. I hope this was useful. Thank you everybody for tuning in. My name is Arpit. We had Aniket with us. I hope you had a good time. I hope this was useful. I hope you learned about what are the different roles that you need to have in your team if you're building a data analytics system for any organization, and what are the tools on Google Cloud that you can use. Leave a comment, like the video, and we'll see you around next week. Thank you.